All right, here we go. This is question number 2 from the 2017 BC International Exam. This is a calculator active question, so definitely get your calculators and get ready for this to be maybe a little bit more of a push than some of the questions that we've seen before. This is my first time actually working through this one publicly, so I'm going to try to take my time, make sure I read this carefully. During the time interval 0 less than or equal to t less than or equal to 4.5 hours, water flows into tank A at a rate given by A of t equals 2t minus 5 plus 5e to the 2 sine of t liters per hour. Okay, so that's this function up here. This is for tank A. During the same time interval, water flows into tank B at a rate of b of t liters per hour. Now, you might notice right away that when we talk about tank B, that's this graph, but at no point have they actually given us an equation for what's going on here with tank B. That's a little different. Both tanks are empty at time t equals 0. The graphs of y equals a of t and y equals b of t, shown in the figure above, intersect at time t equals k and t equals 2.416. So we have an intersection point at t equals k and an intersection point at time t equals 2.416. Okay? In part A, how much water will be in tank A at time t equals 4.5? Well, what do I know? I know that the tank initially was empty, so I've got nothing in there in the beginning. Plus, I'm adding water into the tank from t equals 0 to 4.5 at a rate given by a of t. And I'm going to integrate that with respect to t. Remember, this is calculator active. So let's switch over to the calculator. And for convenience, I already went and I typed the function into my calculator. So I'm just going to go over here. I'm going to go to menu. I'm going to go to calculus. I'm going to go to numerical integral. And we integrate from 0 to 4.5. A of t on my calculator is f1 of x. And I'm getting 66.532. So 66.532, what were the units? Liters per hour. So the 66.532 must represent units of liters. Okay. They offered 1 point for the integral, knowing to integrate from 0 to 4.5, and then 1 point for the numerical answer of 66.532. for a grand total of 2 points. Not too bad. I think that's a pretty standard, very comfortable, approachable question. Now let's look at part B. During the time interval 0 less than or equal to t less than or equal to k hours, water flows into tank B at a constant rate of 20.5 liters per hour. Okay? What is the difference between the amount of water in tank A and the amount of water in tank B at this time t equals k? All right, let me look at this one more time. During the time interval 0 less than or equal to t less than or equal to k hours, water flows into tank B at a constant rate of 20.5. Okay? So tank B, the rate is 20.5 liters per hour. Okay? That's what they tell us. What is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? Well, how are we going to figure this out? During the time interval 0 less than or equal to t less than or equal to k hours, water flows into tank B at a rate of 20.5 liters per hour. Okay, that's my constant rate. what's the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? Well, what was the significance of k? The significance of k is your intersection point here. Let me pull this up. At t equals k, A of t and B of t are the same rate. Ah, that's the key here. So what I need to do is I need to set these two values equal to each other. We've got A of t, the function that they gave us in the beginning. We've got the rate for B of t, which is 20.5, and I need to figure out at what time is the rate that water flows into tank A equal to 20.5. Let's use the calculator. I'm going to go back over to the calculator. This time I'm going to look at the graph. I'm going to add in the horizontal line 20.5, and I'm going to look for the intersection point. So I'm going to do menu, analyze graph, intersection, little to the left, little to the right, and it looks like the value for k that I'm interested in is 0.892. Okay, not too bad. Let's keep going so you can see what I'm writing. Now for tank A, they want to know what's the difference between the amount of water in tank A and the amount of water in tank B at this particular time. Well, for tank A, I'm integrating from 0 to k my function A of t dt. For tank B, I'm integrating from 0 to k 20.5 liters per hour every hour on this time interval. And I want to find the difference between those two. So let's go and let's do it. This 0.892, that value of k, I'm going to store that. We're going to need that for sure. So I've highlighted it, menu, var. What just happened there? Okay, I've highlighted var, store var, and let's call it k. I'm going to go over here and we are going to do an integral. So menu, calc, integral from 0 to k, my original function, that's for tank A. I'm going to then do another integral, so menu, calculus, numerical integral from 0 to k, this time 20.5 dx. And all of that is looking pretty good. So tank A has approximately 7.688 liters in it at this time. Tank B has approximately 18.287 liters. And so if I want to know the difference in the tanks, all I'm going to have to do is subtract difference in the tanks at time t equals k. We can arrow up and say this value here minus arrow up that value there, and we're going to get 10.599 liters. There are some other ways you could have approached this. Maybe you want to do this as one integral instead. Feel free. But let's look at how points would have been awarded. They awarded 1 point for determining the value of k to be 0.8, I'm sorry, not even for determining the value of k, but for setting this initial equation where they say A of t is 20.5. Then they did 1 point for the integral and 1 point for your final answer. So 1 point for the final answer of 10.599. Because I did this as two different integrals, I'm not sure if I'd have to get both integrals correct to get the answer. But this is a 3-point question, and I know we came up with the right answer, just a little bit different from what the College Board has. Let's move on to part C. down a little bit. In part C, we're told the area of the region bounded by the graphs y equals a of t and y equals b of t for k less than or equal to t less than or equal to 2.416 is 14.470. How much water is in tank B at time t equals 2.416? Okay, hold on a second. So they've told me about the area. They've told me that that area here is, what do they say, 14.470. And they're asking me to determine how much water is in tank B. Well, what do we know? Tank B at time t equals 2.416. Well, what have we already done? We went and we figured out, let's see, we had 0 in the beginning, plus on this interval 0 to k, that the water was coming in at a rate of 20.5 liters per hour. Plus, now let's see, B of t is the lower one. What I need to know is how much water, if I'm thinking about this graphically, the question that they're asking is how much water comes in from t equals 0 to t equals 2.416. Okay? So that's this value here. The tricky part is I can find out the integral from 0 to k of 20.5 easily enough. But then what do you do to figure out this area here when they haven't given you b of t? What they did tell you is that tank A, that this area here is 14.470. So here's my thought. I'm going to say the integral from k to 2.416 of b of t dt. Well, that's what I want. But the way I'm going to go about getting this value is going to be a little bit trickier. I'm going to say, let me look at the integral from k to 2.416 underneath the curve a of t. Well, that's going to be equal to the integral from k to 2.416 b of t dt. That's the value that I want, plus the area up here, which is 14.470. What I really want is this value, but since I don't know what b of t is, I can't find this value directly. I do have a function for a of t, so let's see what happens here. We're going to go to Menu, Calculus, oops. Menu, Calculus, Numerical Integral, and we're integrating from k to 2.416 of my original function, which is a of t, and I'm getting 44.497. Let's go back to my paper. The 44.497 is this value over here. That's then equal to the integral from k to 2.416 b of t dt plus 14.470. The value that I need is the value of the integral. Well, I can get that by just doing some subtraction. The integral from k to 2.416 of b of t dt is 44.497 minus 14.470. And if I do that correctly, I believe that's going to be approximately 30.027. Now, before you stop and say, oh, great, I've got it, be careful. What did you just find? You found the integral from k to 2.416. Let me get another piece of paper. What they asked us to find was how much is in tank B. We've got the 0 liters in the beginning, plus the integral from 0 to k of 20.5, plus this value over here is the final value that I needed, which is 30.027. When you type all of that into your calculator, what you're going to get is 48.314 liters. Wow. That was an intense question. And let's see, what I know is they awarded 2 measly little points for all of this beautiful thinking. They awarded 1 point for making the connection with the integral from k to 2.416 of a of t dt. Now, they don't say what you need to do, but just that you're considering it, and then 1 extra point for the answer, for a grand total of 2 points. All right, friends, here we go with part D, the last part of this question. During the time interval 2.7 less than or equal to t less than or equal to 4.5 hours, the rate at which water flows into tank B is modeled by W of t equals 21 minus 30t over t minus 8 squared. Finally, some function that tells me about water flowing into tank B, liters per hour. Is the difference W of t minus A of t increasing or decreasing at time t equals 3.5? Well, think about this for a second. W of t is how fast water flows into tank B. A of t is how fast water flows into tank A. And they want to know, how is this difference increasing or decreasing? Increasing or decreasing at t equals 3.5. The way I'm going to figure that out is I'm going to find the value of the derivative of W minus the value of the derivative of A and determine the sign of this value. So to make life a little bit easier, I already went ahead and I typed W of t into my calculator. There's W of t now showing up as the second function. And let me go on over here. I'm going to go to menu. I'm going to go to calculus. I'm going to go to derivative. W of t is my new function. So I want the derivative of, you could do it as two separate derivative steps, or one. Your calculator doesn't really need you to do 2 different steps. Remember, W of t is for tank B, that was my second function. A of t is F1, that's for tank A. And what I get is that this is approximately negative 1.143, which is less than 0. Therefore, W of t minus A of t is decreasing at t equals 3.5. Okay, so W prime of 3.5 minus A prime of 3.5 is negative. Got you the first point. The fact that the difference is decreasing, that's the right conclusion. That got you the second point. 2 points. Gotta tell you, I liked part C. Part C was a little worrisome though. And then they only gave you 2 points. What was up with that? But you know, the College Board, they're gonna keep pushing and writing new questions. What I hope is that parts A and B and D were pretty straightforward, pretty much what you would expect. I would encourage you to go back and think about part C a little bit more. I know I'm going to as well. Maybe there's a more elegant way to approach it. I don't know that there is, but maybe there is. Best of luck, y'all.